Right. So, in the last sessions, we have discussed about Java data structures, followed by we discussed about even algorithms, etc. All that. Today, I'm going to discuss about the AVL tree, which majorly uh, one of the important concept under data structures when we are working on, because whenever we are using data structures for implementing different data and how this can be streamlined, it's always important for us to understand about using the packages of AVL tree, etc., all that stuff. Normally, when we try to understand about AVL tree itself is concerned, majorly to make it very short, which is a self-balancing binary search tree. This is something, one of the, I can say, one of the data structure which is to be uh, initiated in the beginning days, right? So when we try to see from AVL tree point of view, this is majorly focusing on the different aspects of data structures. What is that are we going to use, right? So by inviting the packages of AVL tree, all that. So hence I'm going to explain you in high level glimpse over the code of AVL tree, how it works, right? So how it looks like, all that stuff. So for that, we need to import Java utility, array list, etc. Because as in when you know all that, it's importing Java dot util, either it can be array list or it can be collections or it can be comparator or it can be list, right? So everything has to be imported in the beginning. So once we have imported, we need to update the public class, right? So which extends comparable public classes what we have used, followed by updating the private AVL node routes, whatever we have, including updating the AVL routes. Even important for us to mention the public AVL tree, which is a root, right? So normally will be taken root as null initially. So when we have taken public AVL tree as root as null, we need to update the public domain whatever is required, right? So wherein, for example, when we have taken some elements, right? So different arguments we are taken, right? So within uh, private AVL which where you are going to add AVL nodes for the roots, such as of T element, which majorly throws the illegal argument exceptions when we have created. For this, we require to write some conditions. This where generally if else condition will work out, right? So if element, for example, is null, right? So when we are throwing new illegal argument exceptions in the one which we want to see is the element you want to add was null, right? So this is something which we need to see over here as a output, right? So this is an if condition, right? So when it comes to the else condition, right? What is an else condition? Else if root is null, then return new AVL node to the element. So this is the condition which to be added, okay? Because when we are implementing this data structures, algorithms, especially AVL tree, etc., always important for us to implement the conditions, right? Either it can be if condition or else conditions, everything we have to be implemented. If condition majorly stating us to identify what final output you want to see. The element you want to add was null, right? This is an output we want to see if exception what we have written, all that. Else, if it is root is null, then it will return to the AVL node element. And this is how generally we normally write. So this AVL tree by taking a public class which extends comparable, etc. Right. So this is about something which normally we will be taken. So when we are writing down the uh, AVL tree, etc., all this. Next, when we want to deprecate it, right? So because it's an iterative method normally, right? So which is useful to add nodes, right? So if the root is given is null, then it will create an AVL node assigning the value to the node. If you want to add any there, like it will not allocate any elements in its place and then will return again to the root. That's how generally this deprecated. You can see it all there here. So for this, we're implementing the deprecated public void uh, add iterative is something we need to be updated, right? So with two different things. One is about the if condition, second is an else condition. If is a condition we have used for an element wherein we are throwing new illegal argument exceptions and all. Make sure if the output can be like element you want to add was null or something. Otherwise, we use AVL nodes where whatever the roots or the Boolean added value you want to be updated. Either it can be a true or false, right? So this is something which we have to be updated here. This is all about the AVL tree.java, something which we use the extension part, the rest part, so that I'm going to discuss in the next session.